All right, in this lesson, we are going to talk about complex numbers and we are going to add, subtract, and multiply them. Okay, and so first of all, a complex number is a number that has a real part and an imaginary part. Okay, and so it's in the form a plus bi, where a is a real number and so is b, and a is considered the real part, the one without the I, and then b is considered the imaginary part. Okay, and so if you do not have this bi part, you're just working with a real number. Okay, so real numbers are complex numbers where the b value is 0, so you don't even have this I term. Okay, and then if a is 0 and b is not, that means you only have the I part, and so those are considered imaginary numbers. They're just imaginary. And so these are sometimes called purely imaginary. Or pure imaginary numbers because they don't have a real part. Okay, and so as far as adding and subtracting these go, you treat I much like a variable, and so it's a lot like adding and subtracting binomials. You combine your like terms. And so for number 1, we would combine the real parts, which are 28 and negative 6, which would give us 22. And then the imaginary part, 3i plus 14i, is 17i. And that's how you would leave your final answer, an a plus bi form. So just adding your like terms. Okay, when you're subtracting, it's much like subtracting a binomial. What I like to do is distribute this negative sign so that it becomes negative 6 plus 2i. And then we're right back to what we were doing in the previous example. We're going to combine our like terms. So the real parts are negative 33 and negative 6, which would give me negative 39. And then the imaginary parts are 5i plus 2i, which is 7i. And so that would be our final answer. Okay, here we're combining 3, but same idea. If you see a negative, go ahead and distribute it. So that gives me a negative 6 plus 14i plus 33 minus 5i. And then there's nothing to distribute on the last set. So now we're ready to combine our like terms. So the real parts are negative 6, 33, and 6, which would come out to just 33. And then the imaginary parts are 14, negative 5, and negative 2i. So that would be 14 minus 7, which is 7i. Okay, this last one has a 2 to distribute. So just like with a binomial, you would go ahead and distribute it, giving you negative 8 plus 20i. And then the real parts are 5 and negative 8 to give me negative 3. And then 3 plus 20i would be 23i. Okay, and so now to talk about multiplying complex numbers, you FOIL them just like you would binomials. The only thing you have to remember is instead of getting an x squared term, you're getting an I squared term. And then remember, I is the same thing as square root of negative 1. And when you square that, squaring and a square root cancel each other out, and that leaves us with just negative 1. So every time you see an I squared is equal to negative 1. And we're going to replace all the I squareds with negative 1s because it's going to become a real number again. Okay, and so looking at number 1, 2 times 5 first would be 10. 2 times 2i would be 4i. 3i times 5 would be 15i. And then last, we would have 3 times 2 is 6. And then I times I is I squared. Okay, and so we know I squared is equal to -1, and we also know that we can combine our i's here. So 10 plus 19i plus 6, and then replacing that I with -1. So that gives me 10 plus 19i minus 6. And so what I like to do is whenever I see an I squared, I cross it off and then change the sign of whatever it is next to, because that's ultimately what you're doing. I squared is -1, which is going to change the sign. Okay, and so we can combine the real parts, 10 and -6, to get 4. And then we have 19i. Okay, same thing here. First would be -12. Outside would be positive 42i. Inside would be 10i. And then last would be negative 35i squared. We have I times I. Okay, and so when you see that I squared, that's the same thing as -1. So it's going to change this sign to a plus. So I have -12 plus 52i plus 35. And then we can combine -12 and 35 to get 23. And so our final answer is 23 plus 52i. Okay, so now we're going to look at some special cases. On number 7, we just have a pure imaginary number, which is technically like a monomial, a single term. And so all we would do here is distribute. We don't have a binomial times a binomial, so it's not necessary to FOIL. And so that would give me -24i, and then 6i times -3i is -18i squared. I see an I squared, that's the same thing as -1, so change that sign. And so my final answer, the real part is just positive 18. The imaginary part is -24i. It's important that you write it in this order, A plus BI. Okay, this next one says 1 minus 6i squared. That's 1 minus 6i times itself. And I encourage you to write it this way because a common mistake is trying to distribute this square, and you cannot do that. You do not distribute a square to a sum or a difference. And so this is a binomial times a binomial situation. And so we FOIL. First would be 1 times 1. Outside would be -6i. Inside would be -6i, and then last would be positive 36i squared. I squared is -1, so cross it off and change this sign. And so that gives me 1 minus 12i minus 36. Combining the 1 and the -36 would give me -35, and then we have minus 12i. Okay, here we have a binomial times a binomial, so 2 times 2 is 4. 2 times -5 is -10i. Inside would be positive 10i. And then last would be -25i squared. I squared is the same as -1, so change that sign. And then our middle term cancels. -10i plus 10i is 0. And so we end up with just 4 plus 25, which is a 29. So our answer is just a real number, 29. The imaginary part went away. Okay, and then this last example, we're multiplying 3. And so a common mistake is trying to just multiply all the reals and then multiply all the i's. And that's not how you do that. You actually have to do these 2 at a time. And so you have to focus on the first pair and FOIL those, okay? And so first would be -10. Outside would be positive 8i. Inside would be positive 15i. And then last would be -12i squared. Okay, and so that gives me -10. 8 plus 15 is 23i. And then I squared is the same as -1, and so that would turn that to a plus 12. And so now when I combine my real parts, it's 2 plus 23i. Okay, and so put that back in parentheses because we still have this other complex number to multiply at the end. So -1 minus I. Okay, and so now when we multiply these, first, -2, outside is -2i, inside is -23i, and last would be -23i squared. I squared is -1, and so I get -2 minus 25i, and then plus 23. Combining the real parts, I get 21, and then the minus 25i. Okay, and so you should never get anything above another complex number. The reason why is because this product results in another complex number. And so you shouldn't end up with more than 2 terms for your final answer because I squared just always comes back to a real number. Okay, the other example I want to point out is that in number 9, notice they're the exact same number, they just have opposite signs. Okay, and so anytime you have that situation where you have a plus bi and then a minus bi, these are called complex conjugates. Okay, and they have a special relationship because the middle term cancels, which means the imaginary part cancels, and the product will always result in a real number. Okay, the imaginary part cancels. So complex conjugates are pretty important. They're used a lot in math in order to turn a denominator into a real number, and so you'll experience a lot of that when you get to pre-cal.